Hi, let's continue with question number 2. A container has a shape of an open ring circular cone as shown in the figure above, right here. The height of the container is 10 centimeter and the diameter opening is 10 centimeter. Water in the container is evaporating so that the depth H is changing at the constant rate of -3/10 centimeter per hour. So this is the depth, the water level. And because the water is evaporating, so therefore the water level will become smaller and smaller. So that means depth is shrinking, it's getting smaller and smaller, so that's why the rate is negative. So now we had the formula for volume of a cone given to us. So let's take a look at part A. Find the volume of the water in the container when H equal to 5. So now we have the cone. This is the water body. Okay. So when H equal to 5. So now we got V equal to 1/3 pi r squared H. Okay, we know H is 5, but we still need to know the radius. So a cone is very special. So you have a big cone and a small cone. So basically all the corresponding part are proportional because the big cone and the small cone are similar. So the radius and this part, okay, in the height with this part, they're basically part of the similar triangle. Okay, corresponding part are proportional. So this is R. If this is 10, so this part is 5. Okay, so this is the water body. And then you chop it and you take this part over here. Okay, two-dimensional, that's how it look like. So this is H. And this is 10. So you can see that you have a small triangle and a big triangle. They are similar. So we have similar triangles. So the R and H are in ratio. So R over H equal to 5/10. So the ratio is R to H equal to 1/2, 1/2. So now you're going to figure out what R equal to. So when H equal to 5, and then you have a ratio. So now over here you can cross multiply. Okay, so we can say that H equal to 2R. Okay, and then divide by 2, R equal to H over 2, or half of H. So R equal to half of H, and H is 5, so therefore 5/2. So now we get R equal to 5/2 and H is 5. We are ready to find the V, the volume. So we go back over here, V equal to 1/3 times pi, and then the radius is 5/2 holding square, and then the H is 5, so therefore times 5. Now we're going to simplify. So you get 25/4, and then you get pi times 25 times 5 is 125. 3 times 4 is 12. So therefore we got 125/12 times pi equal to B. And the unit is going to be in cubic centimeter because it's a volume. So we finished part A. Now let's take a look at part B. Part B. The question said that find the rate of change of the volume of the water in the container with respect to time when H equal to 5. Indicate unit of measure. So we get V equal to 1/3 pi r squared H, and we have to find dV dt. because of the rate of change of the volume with respect to time. So we know that R is a function of time and H is a function of time. Some people may think of using the product rule. Okay. If you recall what we did in part 8, we know that R over H equal to 1 over 2. They have a ratio. And we solved it before. We got H equal to R. And R equal to H over 2. We have H equal to 5, H over 2. Okay, so now that means if you want to, you can use this equation and this equation as a system equation. So we got system of equation. And then we go and substitute R by the H over 2 and convert it into a function v in terms of h. So this way, then you don't have to use a product rule. This will be the more effective way. So we're going to sub r equal to h over 2 into v equal to 1/3 pi r squared h. So v equal to 1/3 pi times h over 2 squared times h. So you can see it. This is going to be in terms of h. So v equal to 1/3 times pi. Then you get x squared over 4 times h. So let's simplify it before we're going to find the derivative. So v equal to 1 over 12 times pi and times hq. Now we are going to find a derivative with respect to time because they are function of time. So dv dt equal to 1 over 12 times pi and times 3h squared times dh dt. We know h is fine. We already mentioned it in the beginning of the question. Dh dt is negative 3 over 10. So now we do substitution. So next step, we just simplify. So we get a pi times, the numerator would be negative 15, denominator would be 8. So you're going to get negative 15 over 8 times pi. So therefore dv dt equal to negative 15 over 8 times pi. And this 3-dimensional, so it would be cm³ per time. The time is in hour. So we finished part B. Now let's take a look at part C. Part C showed that the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area of the water. What is the constant of proportionality? Okay. Direct. Proportional. Y equal to k times x. That is a function for direct proportional. Okay, y is directly proportional to x. So k is the constant of the proportionality. So now we're going to translate this one over here. The rate of change of the volume of the water in the container, so that means dv dt, is directly proportional, equal to k times the exposed surface area of the water. The exposed water surface area is a circle. It will be pi r squared because r change as a function of time. So pi r squared. R is a function of time. So now dv dt. So let's recall what we did in part B. So over here, we got the dv dt equal to 1 over 12 times pi times 3 x squared times dx dt. So now we say that because dv dt equal to 1 over 12 pi times 3 x squared times dx dt, we're going to do substitution. Okay, so now we're going to do 1 over 12 times pi times 3 x squared times dx dt equal to k times pi r squared. So some people ask, why do we do that? The reason is dv dt is also a function relate to dx dt and h. We know h, okay, relate to the r. So therefore, even though we have h over here, so we still can do substitution. H and r have a special relation. And here, h, okay, equal to r because r over h equal to 1 over 2. Okay, so they have a relation. So now over here, we can change the h into 2r. And dx dt was given in the beginning as negative 3 over 10. So it's a constant. So even though we have this, we still can make it into something with the r. So now we're going to do substitution. And h turn into 2r. dx dt into negative 3 over 10. Now we just have to find k. Now we just do algebra. Okay, so we're going to have 1 over 12 times pi times 3 times 4r squared, okay, times negative 3 over 10. Okay, so you found out that 3 and 4 cancel with the 12. Okay, and then you get pi times r squared times negative 3 over 10. Okay, now over here, the pi and pi cancel, the r squared and r squared cancel. So k equal to negative 3 over 10. So the constant of proportionality is equal to negative 3 over 10. So we finished question 2C.